For most illnesses, a vaccine is an almost guaranteed lifeline. But influenza is different.
We have very good measles vaccine, we have a very good rubella vaccine, very good mumps vaccine. All of these viruses in the population haven't changed over the last 50, 60, 70 years. In contrast, influenza changes every year.
The World Health Organization estimates that influenza infects 1 billion of us every year, causing up to 650,000 deaths worldwide. Vaccines are critical, but they're only around 50% effective because they don't fight every strain of flu. So scientists around the world are searching for a shot that fights different strains of the virus, including some that might not even exist yet.
It's really very exciting because you know that you are working for something good that may change the whole world and the health of many people.
This breakthrough would give us lasting protection against influenza, but it might also help us understand how we get there with other viruses too. Difficulty breathing, highly contagious, returning year after year. Hippocrates first described influenza in 412 BC. Since then, the virus has caused annual epidemics. Most notably the Spanish flu in 1918 that killed an estimated 50 to 100 million people worldwide and changed the world in ways that seem all too familiar today.
1918, when the influenza A H1N1 showed up, was during a period of a lot of problems in the United States at the time. World War I was ongoing at that time. There was a lot of movement from rural areas into cities. So at the time, we didn't even know it was a virus. Viruses were kind of still being figured out at the time. So it really was not until the 1930s that we knew the cause of the 1918 pandemic, and then subsequently the seasonal epidemics that we would have every winter, that they realized that that was actually due to a virus. And so from the 30s, it wasn't really until the late 1940s and 1950s that actual vaccines were being used more regularly.
Even though there are just 3 basic types of flu, A, B, and C, type A, which is the most dangerous for humans, has a surface covered in 2 main proteins, H and N. There are 18 different types of H protein and 11 types of N protein, and they combine to create up to 198 influenza subtypes, including ones like H3N2 and H1N1.
The influenza virus is constantly changing. And so if you look at a virus, on the inside of the virus are the genes, and genes are just the recipe, the instructions for making more copies of itself. So if somebody sneezes or coughs and you happen to breathe that in, those viruses that are in those respiratory droplets go to the back of your throat. They grab onto the respiratory cells that are there, they push themselves into the cells, and they release those genes that are in there. Those genes, it's not one long string of instructions, it's 8 separate strings of instruction. And so there's so much opportunity for that virus to mess up in terms of making copies of itself. It's not a very good editor. It really doesn't have good quality control. In one way, that's bad for the virus because it makes copies of itself that may not even live on. They don't even reproduce. But it also means that it can find ways to get around your own immunity and ways to get around vaccines that are being used and to get around antiviral drugs as well.
This genetic shapeshifting is known as antigenic drift and means that our body can't always recognize the virus, even if we've caught it or been vaccinated before. But scientists at pharmaceutical company BeyondVax have worked for almost 3 decades, creating a vaccine which targets parts of the virus that don't change.
All influenza viruses are different in their appearance, but they are still considered as influenza because they have a lot in common. And what the immune system want to do, they want to recognize the virus and to attack it when it enters the body. So we have to teach the immune system how the virus looks like. So what we thought will be more effective and to have a universal vaccine is to show the immune system and teach it to recognize the conserved and common denominator of all influenza viruses. So we constructed a vaccine. It is called M001. It contains 9 such conserved regions from the influenza virus.
Variations between influenza viruses usually happen on the surface. But dig a little deeper and there are similarities in its peptides, short strings of amino acids that are responsible for how the virus functions. M001 is made up of 9 different peptides that our immune system can learn to recognize and fight off in the future.
One of the peptides that we selected in our vaccine is very close to the point where the virus is entering the cells. So it's like a key and a lock, where the key is on the side of the virus and the lock is the entrance to our cell. And if the virus wants to enter the cell and cause the disease, it enters its key into the lock, opens it, and the disease starts to develop. So by our vaccine, we block this key, and the virus cannot anymore enter into the cell, and we prevent the disease.
So M001 is in phase 3 clinical trials. Are you feeling nervous about the results?
Of course, I'm worried all the time. I hardly breathe. Until we get the outcomes of our pivotal phase 3 trial, which is a trial with over 12,000 participants that was conducted in Europe. In this trial, we injected half of the participants with our vaccine, and the other half received placebo, which was saline. And at the end of the trial, which means at the end of this month, we will know how many participants were ill in the experimental group that was immunized with our vaccine, and how many were ill in the control group that actually was not immunized. And if the difference will be high enough, then our vaccine works and we're happy. We'll know if it is safe, if it is protected against influenza.
A universal vaccine like M001 would radically change the way we make our flu shots. Currently, for Northern Hemisphere vaccines, every February the WHO picks 4 strains of influenza, which scientists predict will most likely be circulating in October, the start of the flu season. This vaccine recipe is sent out to manufacturers, and the majority of vaccines are made just like back in the 40s, by injecting the vaccine virus into fertilized eggs. It takes at least 6 months to produce the high quantities we need.
So we have to really, based on what happened 2 months before February, but we are not really good at that, unfortunately.
Dr. Peter Palese is a microbiologist who built the first genetic map of the influenza virus back in the 70s.
The yearly influenza vaccine, I think, is underappreciated, underutilized. So I think there is a benefit in taking the vaccine, because even if you get the flu, it was a failure, but your disease, the morbidity is much lower. Clearly, I think I want to encourage your listeners to take the current vaccine, the current influenza virus vaccine, as an insurance against whatever might happen. Yeah. So it is a very safe vaccine. I think it is a very good vaccine. Having said that, if we want to make a better vaccine, we have to show that it is at least as good as the current vaccine, but also that it really preempts or knows what the other strains in year 3, 4, 5 from now on will be, and also the potential new pandemic strains.
Dr. Palese's team is also part of the race to create a universal vaccine. Like BeyondVax, they're using an area of influenza that doesn't mutate, the stem of the H protein on the surface of the virus.
We are redirecting the immune system towards these conserved regions. And I have to say, I can protect any animal, whether it's a mouse, whether it's a ferret, whether it's a guinea pig, against any strain. So using these constructs which present the conserved domain of the virus. It works beautifully in animals. But remember, mice are not men, ferrets are not humans. I think we make progress, but it is still not there. And I can't promise you that it will be 2 years or 3 years. We cannot really predict how long it will take that we will have such a universal influenza virus vaccine.
With disappointing results in the M001 phase 3 trials, the wait will be longer than some had hoped. But the research and time that's been invested isn't wasted. Far from it. Could the work we're doing to find a universal flu vaccine help in the way that we tackle viruses like COVID-19?
Absolutely, and the other way around too. And so the work that now, with significant resources and speed being put into COVID right now, could have a significant impact on flu vaccine choices. If you have a system in place where you can make those kinds of vaccines fast, as soon as you see an emerging pandemic influenza, you can start making vaccine immediately. So faster vaccines. And so I think we'll learn a lot about that with the COVID vaccines as well. So all of that together, we would love to see what we're learning with COVID be applied to flu, because what we're doing right now with COVID is highly informed by what we were doing with flu previously.
What would be the next steps if we got a universal vaccine?
What would be wonderful is to get to that place where flu vaccines aren't something that are just for middle and higher income countries. That low and middle income countries globally have a significant impact of flu every year, but a program to vaccinate children and adults every year in a country with billions of people is really complicated and can be pretty expensive. Coming up with a simple solution that can be rolled out in a programmatic way where it's cost effective for that country to do it would have a significant impact for a better functioning country.